Hi, sir. I'm Dhruti, and here is the level 1 code. So, let me now explain the identifier recognition code in this from this code. So, in level 1, the program checks whether the given string is a valid or not. Um, yeah. The function checks identifier name here and then identifier name, and it is created for validation. And first the program stores all alphabets and digits in separate variables. And then first condition checks whether the first character of the input string is an alphabet or not. And if not it is an alphabet, then the program immediately returns invalid identifier because the identifier cannot start with numbers or special symbols. And next is the program uses a for loop to check the remaining characters here, and one by one remaining characters one by one. And here if any character is not an alphabet or digit, the identifier becomes invalid, and or otherwise the string is accepted as a valid identifier. So finally, test inputs such as X, total one, and someone are checked, and the result is displayed using a loop and the print statement. So here is the output of the level 1 code, which is identifier recognition code. So here total one is a valid identifier, and sum two is a valid identifier, and ABC is a valid identifier, and 1x is a invalid identifier. As I explained the code, based on this, it is here is the output, and AB minus C is an invalid identifier, and dollar $B is invalid identifier. 123 is also an invalid identifier. So here is the um. So here we go to the level 2 code. So in the level, let me now explain the level 2 code, which is mini lexical analyzer code. So here in level 2, the program acts as a simple lexical analyzer. The code first defines list for keywords, operators, and delimiters. Delimiters. The function lexical analyzer here, the function lexical analyzer programs which lexical analysis program reads the mini ATC program character by character and separates it into tokens like space, tabs, and new line characters are used to split words, while symbols like semicolon, comma, and are treated as delimiters. After token separation, the program identifies the type of each code, and if the token matches a keyword such as begin, end, int, or print, it is displayed as a keyword. And operators and delimiters are also identified separately. The function says is digit, and is identifier are used to recognize numbers and identifiers. Any token that does not satisfy these condition is marked as invalid here. And finally, the lexical analyzer process like the mini ATC sample program and displays all generated tokens with their types. So here you can see the code. So after this code, here is the correct output for the code which I have explained now. Level 2 code. So here, based on the explanation I explained and based on the code here, so here is the perfect output. So here in first column it is token and second is type. So for example, there is a begin token and the type is keyword. Next is int keyword, X identifier, and colon is delimiter, and X is identifier again, and is equals to is an operator, and 10 is a number, and colon is a delimiter, print is a keyword, brackets, X, bracket close, and colon, end. These are all delimiters and identifiers. X is an identifier, but end is a keyword. So after this, we move to the level 3 code here. Here in level 3, yeah, here in level 3, let me now explain the level 3 code first. So in level 3, which is lexical analyzer plus parser code, okay, parser code. So in level 3, both lexical analysis and parsing. The first part of the code is the lexer, which converts the mini ATC source program into tokens, and the lexical and the lexer separates keywords, operators, delimiters, identifiers, and numbers similar to the level 2. Okay, same as level 2 only. And the second part is the parser implemented using the parser class. The parser checks whether the sequence of tokens follows the grammar rules of the mini ATC language, and the match function varies whether the expected token is present. If the expected token is missing, um, system or if the expected token is missing, like a syntax error message is generated, or the function parse program checks the overall program structure, ensuring that program starts with begin and end with end, like it must follows end with end. Okay, and then the here the statement function validates declarations, print statements, and assignment statements, and the expression function, term, and factor functions are used to validate arithmetic expressions according to the CFG rules. CFG in the sense context free grammar. Okay, if all statements follow the correct syntax, the parser displays parsing successful, as you can see here. And after that, after it showing the parsing successful, so valid a mini ATC program, otherwise syntax errors are reported. So here is the expected output for the code for level 3. So here, yeah, you can see as I explained here, it would show that parsing successful or invalid. So here it has shown successful. Thank you.